Okay, the purpose of this video is to show you additional examples of working with random variables, specifically how to combine random variables. So first, some preliminary work. Given random variables x and y, the following things are true. If I want to know the mean of the sum or the mean of the difference, then that is equal to the sum of the means or the difference of the means. In symbols, here's what I'm saying. If I want to know the mean of a variable that's been formed by combining x and y through addition or subtraction, then I'm saying that I take the original mean for x and add it or subtract it from the original mean of y. So the sum or difference of the means is the same as the mean added together or the means subtracted from each other. Point 2. The variance of the sum or difference is always equal to the sum of the variances. I never subtract variances. This is very important. Students make this mistake all the time. So here's what we're saying in symbols. The variance of a random variable that's formed by either adding or subtracting values of x and y is always the sum of the variances. Notice I'm not putting a subtraction symbol here. The sum or difference of the variances, or the variance of the sum or the differences, is always equal to the sum of the variances. Notice here that x and y must be independent. We'll talk about that in a different slide. Again, we never, ever, ever subtract standard deviations. Always go back to the variances. The variance is the mother of standard deviation, so begin with the mother. Then take the square root, give birth to the child. The last point, and we'll deal with this more in class, any variable formed as a result of the combination of independent, normally distributed random variables will always result in a normal distribution. In other words, the shape does not change. If I combine normal with normal, then I get normal when I'm all done. Now let's take a look at some other things. One, when we're looking at independent random variables, we had a definition of independence in the last chapter that had to do with knowing the occurrence of one event, not changing the probability of the occurrence of the other event. And we're using that here. So if knowing whether any event involving x alone has occurred tells us nothing at all about the occurrence of any event y or vice versa, then x and y are independent random variables. Always ask yourself if the assumption of independence is reasonable. We will do this over and over again for the rest of the semester, so please get used to that. Now an example. You can find this example on page 370 of your textbook. Check your understanding. I would suggest that you pause the video at this point and read over it. And I will jump straight into answering questions or answering the questions that are being asked about this particular problem. First of all, we were asked to define and interpret mu t. And we were given information that mu t was the mean for the total number of cars sold or leased. So t was defined as x plus y. So in asking for mu t, I'm asking for mu of x plus y. I apologize, that should be a y here up top, not a t. From what we just saw, we saw the mean of the combination of random variables is just the means, in this case, added together since we're combining through addition. We were told that the mean of x was 1.1. And we were told that the mean of y was 0.7. Therefore, the mean of t is 1.8. Now, we're also asked for an interpretation. Remember that this is a mean. So, on average, or in the long run, this dealership leases or sells 1.8 cars in the first hour of business on Fridays. Being able to interpret the mean is very important. It's key to showing that you conceptually understand what's going on. Let's move to the second question that was asked. Now we want to compute sigma t, assuming x and y are independent. Now, even though we're being asked for the standard deviation, we cannot just add the standard deviations to each other. We must go to the variance of t. Variance is the mother. So the variance of t is the variance of x plus y, which we know is the variance of x plus the variance of y. Now, we were given standard deviation, so in order to find the variance, we're going to have to square these and then take the square root. So the variance of t is 0.943 squared, which is the variance of x, plus 0.64 squared, which is the variance of y. So, if we do that, then take the square root, we're going to end up with standard deviation. So standard deviation is the square root of this 0.943 squared plus 0.64 squared. And if we do our math calculations correctly, we find that we have a standard deviation of 1.14 cars, which says that the average that we got here of 1.8 cars could vary by as much as 1.14 cars. The third thing we were asked to do is to consider that there was a $500 bonus for each car sold and a $300 bonus for each car leased, and asked to find the mean and standard deviation of the manager's total bonus, B. So I've come up with a formula. We're going to multiply how many cars were sold by 500 and how many cars were leased by 300. So we need mu B. Now this will take the idea of transformations that we talked about in class and combine it with adding random variables together. So mu B is like saying mu of 500x plus 300y, where this is a variable. Well, this is the same as mu of 500x plus mu 300y. We looked at in class today that taking 500 and multiplying it by every value in the random variable's outcomes creates 500 times the original mean. Likewise, multiplying every value in y's distribution causes the mean to increase by a factor of 300 as well. So now we just have to take 500 times the mean for cars sold, add it to 300 times the mean of cars leased. So this becomes 500 times 1.1 plus 300 times 0.7. And so we get an average bonus of $760. For standard deviation, I'm looking for sigma b. But I must go back to the variance. And so what I'll do here is make sure that I take the square root to represent the variance. It's going to be the square root of the standard deviation of x squared plus the standard deviation of y squared, but we have to include those 300 and 500 multiplications. So the standard deviation would be the square root of the variance of 500x plus the variance of 300y. What I'd like to show you now is that variance is going to come from multiplying not just 0.943 squared, but the standard deviation changes by a factor of 500. So My new variance includes that. For 300, the standard deviation is going to change by that factor of 300, so I need to multiply 0.04 by that and square it to get the variance. If we do our math calculations correctly, we'll find that the average of $760 could vary by $509.09. Next, we want to take the same scenario and ask some questions about the difference. So if you'll now go to page 373, we now want to define D as the difference between X and Y. The difference in the number of cars leased and the number of cars sold. So if I want to find D based on what we've seen, this is the same as mu of X minus Y, which means I just subtract the means of X and Y. So now I have 1.1 minus 0.7, which gives me 0.4. And again, an interpretation here would say, on average, 0.4 more cars, since this is a positive difference, are sold than leased. Number two, assuming that X and Y are independent, we want to find sigma D. To find sigma D, the standard deviation, means to find the standard deviation of the differences. Recall that I told you that we always go back to variance. And when we go back to the variances, I share with you that the variance of the sum or the difference is always equal to the sum of the variances. We will never subtract variances. So you want to make sure that you keep that in mind. That might be something you want to star or highlight in your notes. So in this case, I want to make sure that I go back to the square root. Since variance is the mother, I have to take the square root to get the standard deviation. This is the square root of the variance of X added to the variance of Y. And we made this calculation before. So it shouldn't surprise you that this number looks similar. So this is the square root of 0.943 squared plus 0.64 squared, to which we saw was 1.14 cars. The last question assumes the same bonus, $500 for each car sold, $300 for each car leased, and we want to find the mean and standard deviation of the difference in those. So I'll define a new variable. I'll just call it P, and we want P to be 500 times each car minus 300, each car sold minus 300 for each car leased, and we're being asked for mu P and sigma P. Mu P is mu of 500x minus 300y. Multiply every value x can take on by 500. The mean gets multiplied by 500 as well. We're going to subtract the mean that results from multiplying every value of y by 300. The mean of y will increase by a factor of 300. So this becomes 500 times 1.1 minus 300 times 0.7. If you do some nice math on your calculator, you'll find that the difference is $340. So on average, we're going to get $340 more in bonus for cars sold than leased. Sigma P, we want sigma of 500x minus 300y. Remember that we go back to variances. So this is the square root of the variance of 500x added to the variance of 300y. We'll see that this becomes the square root of 500 times 0.943 squared plus 300 times 0.64 squared. You'll recognize this number as we've seen it before, $509.09. I encourage you to watch this video as many times as you feel necessary. Don't forget to ask questions tomorrow in class, and certainly complete the 5-question quick quiz that will make sure you understand what you saw in the video and what you understand about these concepts as well. And I will see you in class next time.